Something unexpected happened this morning. My Alexa Echo holder broke down and fell off the wall, which was, I'm going to say, not quite unexpected. I was expecting that to come down someday, and here is the broken part that came down. One of my good friends, actually designed and 3D printed this stand for me almost 2.5 years ago. So this model was well constructed and served for more than 2 years. So it's pretty amazing how this worked out. However, um, it came down at the predetermined, I must say, or pre-estimated breaking point, where the moment was the maximum. I remember I was discussing with my friend that will come down there. So here's a video of the broken part, where I was trying to actually see what the profile was. So that holder part is still on the wall. I'll probably try to glue it up to fix it for now. And I was spending some time try to recreate the model. I could have asked my friend for the original design. I'm sure he has it on his device somewhere. But this is the idea. So you can see, as I can show it here. So that's the round plate, like a helicopter pad, helicopter landing pad. That's there, and it comes down as a curve, comes up, goes parallel to the horizontal, and connects with the wall. And that's what I tried to recreate. Mine probably a little wider than what actual model is, but you get the idea. So this is the one, that's the model that I was trying to see how to, if I did this model for a second time, what lesson learned would be for me to actually redesign this model so even after 3 years it won't come down. And I'm thinking, uh, trust, the principle of trust, I could apply it here and then make up probably a better model for this. So today, in this weekend special, I welcome you to witness me modify this existing model, so it won't break down after 3 years. I will be reconstructing this existing model and then modifying it to see what can be done. Wait, because I want to show respect to the original designer, I won't be modifying this original idea. I will keep that and then try to improve it. So that's one way for me to show respect to my friend. With that, let's get started on this one model where I actually build something that will be used in practice. I know for last 50 days I've been building models every day, one fictional model. That's good for learning experience, but I don't think they will be coming to any everyday use. Today is the first time I'm going to attempt something designing that I will be using in my real life. So let's get started then. What I want to do is I want to start from the support on the wall, and that will be pretty simple sketch, and I want to build that on probably right face on YZ plane. So on the YZ plane I want to take a circle. Now I will be taking idea from the model, but I'll probably won't be taking the dimensions exactly. That will be another field where I'll be modifying my own dimensions. So I want to make this inner hole half-inch diameter, maybe 18 millimeter diameter, and then outer hole would be say 30. I want to make that base a little bit wider so it will give me more space which in a sense, which one way to say it will give me more moment resistance when actually the model is finished. So this is the model that I want to do. While I'm here, let me go ahead and then make those tiny screw holes that I will be working on. Now this is the original configuration, two at top and one at the bottom. I want to get out of that idea because I have something else in my mind. I want to make it like this, two at the bottom, one at the top. I know it's a tiny little thing, but still I want to do it because that will be interfering with my entire model later on if I didn't do it right now. So this is one field that I will be explaining a bit more when the final model is completed. For now, let's make them construction geometry and make an angle between them is 120. And the angle between these two also 120. And I want to make all these three equal, and let's see how far we can make it. I want to make that length as say 25. That looks good to me. For now, I want to make them radius of 2 millimeters, so I can actually 1.5 will do. Yes. So that's my support. I want to pad that up by 10 millimeter will do. That's pretty good. That's my support that goes against the wall. These are the three screw holes that will fix it with the wall. On that, I want to build a profile here that will go hold the plate. To do that, actually, I want to get some idea about how big this object is. I search on the Google for real quick what would be the dimension for this Amazon Eco 4th generation. It says 5.7 inches in diameter, and there is 5.2. As I remember, this is a spherical object, and it says 5.2. So let's take a deeper look at what it is. So the diameter is 5.7 this way, and on z direction that's also 5.7, but they have cut out some of this sphere to make it flat, and I'm thinking that's the 5.2 inches is like it would sit on the flat surface with that. So this is 5.2 inches or 133 millimeter. That will be important for us. So 144 millimeter is the diameter of the sphere that I want to build to have some idea. So I want to build a sphere that's say Eco 4th gen. Okay, that's our mock object, and the radius would be 144 over 2. Was it 144? Yes. Now that's our object. Let's move it out of our way. So this is the wall. I want to keep it somewhere here. Okay. All right. And remember that this little part there will be cut out, and it will be flat and like a plane, horizontal plane. And one way I can do that is, I'm thinking I can make a cube, say make it 200, 200, 200. It's probably too much, but I can take this Eco 4th gen and move it up somewhere there. Okay, and keep the echo, delete the cube. Didn't work. Too soon. I did it too soon. I'll have to move this cube like that. Okay, let's make sure it's covered by entire thing. Now I can make the cut. I want to keep the cube echo, delete the cube. There it is. So that's the idea that I have to actually make that flatten, where this deleted part would be actually my base. So when I put the cube, when I put the echo on top of this base, it will be a whole sphere. That's the idea. So let me bring my cube back. I will have to update this cube a little bit more. So I want to make this width 145, right? Length 145 and height 145. So remember, this sphere is 144 in diameter, and I made the cube 144. I want to position it. So on the Y, I'm going to say minus 144 over 2. So that puts it in the middle. And this one, let's bring it such a way that it won't be showing anything on either side, right? Okay. And how about this part? How much do I want to keep it? That's where actually our measurements here comes into play. 144 and 133. So the difference is the one that I want to keep. So 144 minus 133, that's 11 millimeter. I want to, so this cube is at z wise, it is at 0. And on the ecozine, I want to make this 0, 2. Now that's the center. How about I make it 72? Okay, so this cube, let's make that a little bit half transparent, 50. As you can see, the sphere is touching the cube. So that's what we want this to be for now. What I want to do is take the ecozine, eco-forgin, and then bring it down by 11. So whatever part of this echo inside this cube, that's the one that I already have in my house. And the part that's not within the cube, that's below the cube, is the one that I want to build. It's the idea. So I can make that cut later on. For now, I am just going to bring the transparency to 0. Okay. Let's hide this cube for now. Maybe this one. No, I want to keep that. Okay. So that explanation is done. Now it is time for us to work on this curve, this handle. I need this reference to do that job. So let's start working on, we will be building that plan on XZ plane. XZ plane, okay. What I want to do is, I want to bring in a line and make a curve. Maybe I have to, okay. How about I take this line as a reference? I want to take this line as a reference, okay. And now I want to hide that. All right. So easiest way to do is draw a line take endpoint dream points maybe up to like that, and take another one, bring it about here. Okay, we'll keep it simple. Okay, and I want to bring in this line as a reference so I can hook it up with this line. Maybe I want to there. So that reference is done. I want to keep these two in line. Maybe not in line. Maybe I want to keep them at a distance. So I want to make them at a distance, say 5 millimeter. For now, we'll come back to this later on. Okay, apply some tangency between this and that, this curve and this curve, and let's bring back the echo. Okay, right. That looks about right? Yeah, maybe make this a little bit deep. Yeah, it's about right. So that's the one that we want to keep. Let's put some constraints. This is 16, I'm gonna say 15. Make them round. This is 45. And finally, this would be 40. Right. So that's our profile. Pretty easy. To close it up. Secondly, I want to build another sketch on this face here. So YZ face. On YZ, okay, I want to draw just a circle. I want to probably make it say 5 millimeter in diameter. Alright, so this sketch I want to place it on this line. It's normal to edge, that will do. How about I make a sweep? I want to take this one as the sweep section, create a solution. This is the path that I want to take on. Done. So I selected create solid. There, that's our first arm. Let's bring back echo. Looks about right. Okay, so main thing is done. Not what I want to do is I want to move it from the center to here. Easiest way to do it is use the transfer and transfer it right about there. Alright, now I have to duplicate this on the other side too, and we can do that by mirror, and the middle plane is XZ plane. Okay, right, I want to hide this and that, and these two I want to make them one unit. Actually, I can do one better. Bring the echo back. I want to make all three one unit. Now I want to take the cube out of the equation. Whoa, that was easy. Yes, this is a little wider than what it is now actually. So this is much more what it looks like. So this is the stand that my friend designed and printed for me. So thank you, friend. As you can see, the centerpiece was not there. So what I did, once he brought this one to my house, I made a drilled hole. I drilled a hole through the center, and it's kind of like it's a piece of bamboo. Okay, and that would go through the eco holes, center hole, and hold it in place. So we modeled this piece. That was easy. Now on the second part, what I want to do is I want to improve on this idea. I want to improve on this idea to see if I can make it one better. My idea is to add a third leg and apply some truss principle to this model. So that way this plastic material from 3D printer would not be in so much stress that it would come down after 2.5 years. We can do that easily. So the idea is I can take this arm a little bit up and bring in a third arm here. So let's work on that. Let's work on that part. To do that, I want to take this cut down. I want to take it back for now, hide this cube, and probably delete this fusion for now. Right? What I want to do is I want to work on this sketch. So this is horizontal, this is on point now. Why it is, oh, it says it's on this sketch. So I took that constraints off. Now it is free to come down or up. Maybe I want to take it up. Okay, I want to take it up here and then place it there and give them a height, say 10. Right? Let's take a look at it now. Okay, so I'll have to update the location of this. So it says on the Y direction is 23. How about I make it 20? 21 maybe? Maybe 22. Yeah, that will do. 22 will do. Okay. So I did that. See, that's why I wanted to make this circle, the base circle, a little wider so I could do this adjustment. That's what if it was too little, that would not give me much leverage. Now I could take it a little bit up too, but it looks good for now. So it's 10 millimeter away above of the center line. I think that's enough. Yes, I think that's enough. Okay, now what I want to do is I want to take both of these sketch and make a copy of those, okay, and put them outside. So 3 and 4. I don't want to worry about 4 right now. I'm gonna say this is sketch arm profile. I don't want to worry about that right now. What I want to do is I want to work on this sketch. Let's hide this sweep and this one too. Maybe hide this echo for now. Okay, so this is the one that we want to take down. How about I make this -10? Maybe a bit more. Yeah, 23. Okay, that seems about right. And this looks pretty weird. So how about I delete this constraint and make it look like that. So this will be when finalized, when in action, this arm will be in compression and the top two will be in tension. With that, I want to probably, what I want to do is I want to update this one too. I want to make it -10. Yes, That should give us some base resistance. And let's constrain this now as 70. Looks good, right? Hit close. Okay, so that one is there. It's almost touching. I think that's okay. We don't have to be perfect in there. All right, now what I want to do is I want to make a sweep for this one. So this is the sweep profile, and I want to take this sketch as our path. All right, let's bring this sweep back. How does it look? It looks good. Okay, that will give us some leverage against this weight. All right, let's bring our echo back. So I want to make echo 1 arm, 2 arm, 3 arms as one object, and take the cube. Okay, so that's not unexpected. This cube is cutting through these arms. Let's take care of that. I want to take it by say 25. And where is I think that looks good. Okay, so this is the fusion I want to keep. This is the part that I want to delete. There, you see something here? It's probably that sketch. Okay, there, that's the one. So this was the original, a little longer, but this was the original, where the weight of this echo, the weight of the object, was putting these two, the top surface as in tension and the bottom one in compression. Since there is no reinforcement in there, it broke down. This model will act in like as a little bit stronger, where both of these will be in tension. Now plastic is weaker in tension, but that's why we have two of them up there. It is compression, it is good in compression, like concrete. So it's stronger in compression. So we have one bar down there and two of them in tension. So whatever the strength it was previously, just a ballpark number, it's probably 3 times stronger now. So if the previous model has worked out for like say 2.5 years, this should be good for 10 years. I mean, that's just estimation. I'll have to do some FEM analysis on this one. I don't know how to do that on in FreeCAD yet. Maybe that's something that I will work on in my next holidays. But for now, this is the object. That's the object that I wanted to modify, the existing model. And hopefully my friend will print this one for me probably in over the next couple of months. I hope you enjoyed this process. I was really excited about this one when it came up to me, when the echo broke down this morning, this stand. The first thing I thought, oh, that's a bummer. And then I thought maybe I would modify this model and then see actually how it performs compared to the previous one. I wanted to have you with me in that modification, and thank you for that. I will see you next week. Enjoy the week in the meantime. Bye.